Today, we're building the Aura AQ air quality monitor. I have two versions here, the original model with a 4.3-inch screen and Adafruit sensors, and the massive 7-inch Aura XL. This video is split into two parts. You can see the timestamps on the screen right now. In the first part, we'll assemble the original case and connect the DFRobot SFA40 sensor. In the second part, we'll build the Aura XL, and I'll show you how to connect my custom PCB. Let's dive in. For anyone new here, Aura AQ is an open-source smart air quality monitor, and our crowdfunding campaign is actually live right now. If you missed the initial launch, don't worry. The late pledge option is open, so you can still jump in, back the project, and secure your own device. If you want to see a full deep dive into what this device can do, I highly recommend checking out my previous overview video. I'll leave a link to it right up here in the corner. I also want to say a huge thank you to MakerWorld for this incredible opportunity, and of course to all of my backers for your amazing support. Thanks to every single one of you, I get to do what I love most every day. I've put my heart into this project, and I sincerely hope it brings real value to you and your families, helping everyone breathe cleaner air. I've placed a QR code for the project page right on the screen, and you can also find all the links in the description below. A few words about the new PCB. This custom board already features a built-in pressure sensor and a RTC module. It also includes a power stabilization capacitor, a pin header for DFRobot sensors, two Stemma QT connectors, a dedicated SEN66 connector, a Grove connector, and 3 extra PH 2.0 connectors. Thanks to this design, the only cable you'll actually need to buy separately is the 6-pin cable for the SEN66. We'll dive into all the details in part 2. Huge shout out to PCB Way for manufacturing these. They did an amazing job, and their speed and quality are absolutely top-notch. I've placed a QR code on the screen right now that takes you straight to the project page so you can order the board directly. Also, if you check the BOM list on the project page, you'll find a list of local resellers where you can order this PCB as well. Let's start by preparing the main I2C cable that connects our WaveShare board to the Adafruit modules. This is the original cable bundled with the WaveShare board. It won't work for this build because the other end has a male pin header. However, you can use it as a reference for the pinout. Here is the cable I recommended in the BOM list. As you can see, the red VCC wire and the black GND wire are in the wrong positions. We need to carefully remove these pins from the connector and swap them, using the original cable as a guide. Leave the other two wires as they are. To do this, take a small flathead screwdriver. Gently lift the plastic retaining tab and slowly pull the wire out. Now, insert the wires so they match the original cable layout. Double-check your work, and if everything looks good, wrap a piece of electrical tape around one end to mark it. Just in case you ordered your cables from AliExpress and have different wire colors or layouts, here is the pinout for both the Adafruit and WaveShare sides. Use this diagram as your reference. Now, let's move on to the Adafruit modules. We will need the SEN66 breakout board, an I2C hub, a pressure sensor, and an RTC module. Connect the modified cable we just prepared from the WaveShare board to the I2C hub. Next, connect the Adafruit modules to each other. With that done, we're ready to prepare the cable for the DFRobot sensors, including the SFA40. I don't have the SFA40 sensor on hand right now, but all DFRobot sensors share the exact same connectors and pinouts. So, I'll demonstrate the connection using a DAC module and a CO sensor, which we also use in this project. This is the stock cable that comes with DFRobot sensors. We can't use it as is to connect to the Adafruit hub, but we can modify it to make the cable we need. More on that in a moment. Now, this is the cable from AliExpress that I recommended in the campaign updates, where you can also find the link. The connectors fit perfectly, but the pinout on the DFRobot connector side is completely different. Don't worry though, we'll use the same trick we did with the WaveShare cable, except this time, we need to swap all 4 pins on the DFRobot connector end. I've put the wiring diagram on the screen for your reference. And there we go. The pins are in the right places and this cable is good to go. Now, we also have a second option, making the cable completely from scratch. To do this, we'll need to snip the connector off the stock DFRobot cable and splice it with a connector from any standard Stemma QT cable. For this method, we're going to need a soldering iron. I'm intentionally avoiding any specialized wire stripping tools here, just to show you that you can easily do this with whatever you have lying around. Let's strip the wires using regular flush cutters. You'll need heat shrink tubing to insulate the wires after soldering, so remember to slide it onto the wire before you twist them. I'm using 1.5mm tubing here, but I'd recommend going with 2mm, or 2.5mm instead for an easier fit. Keep in mind, you should never use electrical tape here, as it can affect the air quality sensor readings. Next, twist the wires together, as shown in the image on the right. Make sure to match them by their pin position rather than the wire color, since your QT cable might use a different color scheme. I'm using flux in a syringe because it's just more convenient for me. Any standard no clean flux works perfectly here. For solder, any decent quality solder will do. Now let's bring out our soldering iron. Yes, I know what you're thinking. I deliberately grabbed this absolute unit of a pulse soldering iron with a massive tip. It looks like it belongs in a car repair shop, but I wanted to prove that you can get the job done even with heavy-duty tools if that's all you have on hand. By the way, if you don't own a soldering iron and are looking to buy one, there are amazing modern options out there today. Some are USB-powered, and others even have built-in batteries. YouTube is packed with great reviews on them. Carefully solder the joints, making sure not to overheat the wires so the insulation doesn't melt away. Everything is soldered. Now, it's time for insulation. Slide your heat shrink tubing over the exposed joints and heat it up until it shrinks tightly for a secure fit. Great, our cable is ready. Now let's move on to the final part of the assembly. Just a quick heads up. Depending on component availability when you ordered, your pressure sensor or RTC module might look slightly different. I added a few alternative options along the way as parts went out of stock, but the connection process remains exactly the same. For this build, we need a capacitor. I've shown the exact way to wire it in the written instructions. We'll be connecting it to the SEN66 breakout board using a standard Grove to stem a QT cable. Honestly, you can skip the screw terminal entirely if you prefer. Just solder the capacitor directly to the VCC and GND wires of any QT cable. Next, plug in the 6-pin cable for the SEN66. It's a real shame that Sensirion didn't include this cable in the box with the sensor. Also, a quick warning, there have been a few cases where third-party cables had flipped or mixed up pins on one of the connectors, so please double-check yours just in case. After that, connect the custom cable we prepared earlier for the DFRobot sensor. Finally, let's screw on the second part of the bracket. By the way, don't forget to install the battery into the RTC module. As you can see, I actually forgot to do it myself here. Now, attach the bracket with the Adafruit modules to the WaveShare bracket. Yes, it takes a little bit of effort to get that first bolt lined up with the hole, but on the bright side, this design print's completely support-free. When handling the WaveShare board, make sure to hold it strictly by the edges. Avoid touching the electronic components or the ribbon cables directly. Now, carefully thread the I2C cable through the designated hole in the bracket and plug it into the WaveShare board's I2C port. The board slides perfectly into the slots, so there's no need to worry about alignment. Once it's in place, secure it from the back using 4 screws. With the board secured, it's time to plug a USB-C cable into the top UART port and flash the board using the web installer. The written instructions explain exactly how to do this and include your backer code. Once the flashing process is complete, the board should power up, which means everything is working perfectly. Now, we can unplug the power and move on with the assembly. Next, mount your SFA40 using the dedicated bracket and plug in the custom cable we prepared earlier. Now, connect the wires to the capacitor and the SEN66. You won't mix up the wires because all the connectors are physically different. Since I don't have the SFA40 on hand right now, I'll show you the next steps using another DFRobot sensor. Because all DFRobot sensors share the exact same connectors and pinouts, I'm going to plug in this CO sensor I have here just to demonstrate that everything works perfectly. Let's turn the power on. On the boot screen, you can see that all the sensors are successfully detected. A dedicated card for the CO sensor appears, showing that it's currently in warm-up mode. About 5 minutes later, the sensor has fully warmed up and everything is up and running. That wraps up the assembly with the Adafruit modules. Now, let's jump into part 2. Building the XL enclosure with the massive 7-inch screen and my custom PCB. Let's start by installing the screen and board assembly into the front frame. Be extremely careful here. The screen glass is very thin and fragile around the edges. Avoid touching the electronic components directly, as they are highly sensitive to damage and static electricity. Always try to handle the board strictly by its edges. Place the board face down on the table and lower the frame over it. You'll notice there are special recesses modeled into the frame on the side with the USB ports for a perfect fit. Secure the frame using the stock screws from the Wave Share kit. Don't tighten them all the way down just yet. Flip it over first to double-check that the board is sitting perfectly straight and centered inside the frame. On this 7-inch version, there is a dedicated switch that we need to set to the UART1 position. Plug your USB cable into the UART1 port and proceed to flash the board using the web installer, just as described in the written instructions. After flashing, the board should boot up and load the user interface. If everything looks good, we can disconnect the power and continue the assembly. In the print profiles on the MakerWorld model page, you'll find a separate bracket designed specifically for the PCB. The board is secured with just 2 screws. Be very careful during this step. There are tiny components on the board, and you definitely don't want to slip and damage them with your screwdriver. Now here is where the real fun begins. With this custom board, you don't have to mess around with swapping pins or making custom cables at all. Simply take the stock cable that came bundled with your WaveShare board and plug it into the side pin header. The pins on both the custom PCB and the WaveShare board are clearly labeled. Connect the black wire to GND, red to 3.3 volts, yellow to SDA, and white to SCL. And yes, remember to install the battery for the RTC module this time. Finally, secure the board bracket to this internal partition using 4 screws. I've designed a specific cutout to route the wires in the right direction. Carefully thread the cables through it one by one, just like I'm doing here. To make things easier, let's connect the 6-pin SEN66 cable right away. As a reminder, this is the only wire you actually need to purchase separately. Make sure to double-check its pinout. as a few backers have reported receiving third-party cables with swapped pins. Next, to connect your DFRobot sensors, whether it's the SFA40 formaldehyde sensor, a CO sensor, or a DAC module, you can simply use the stock cable that comes in the box. Plug its pins into the pin header on our custom PCB. I designed the header to match the exact pin order of the stock cable. First is 3.3 volts, second is ground, third is SCL, and fourth is SDA. In my build, I'm plugging in two cables because I'm using both a CO sensor and a DAC module. Once connected, it should look like this. For my formaldehyde sensor, I'm using an older SFA40 from Seed Studio that I had in my spare parts. It comes with a Grove cable, so I'll just plug it straight into the matching Grove port on the board. Now, let's mount the sensors into their slots. In your case, you'll be installing the SFA40 using the dedicated adapter mount from the print profiles. By the way, Sensirion is releasing an official SFA40 breakout board with a connector very soon, and I'll be sure to let you know in the campaign updates. Alongside it, place our main SEN66 sensor into its position. Finally, plug the cables into the sensors. Now, let's screw the internal partition to the base assembly. If you are using both a CO sensor and a DAC module, you will need to print this optional bracket designed for this specific enclosure. Mount the DAC module onto the bracket. Just a quick reminder, the active channel is Vout0. This DAC module can automatically control an exhaust fan using a 0 to 10 volt control signal. Next, let's install the CO sensor. Now that the sensors are in place, we need to plug in the connectors. You also need to connect the exhaust fan cable right now because access to it will be blocked later. But I'll skip that step for now and just screw our bracket to the base. With that done, since the DFRobot cables are quite long, let's neatly tuck them inside the enclosure before installing the top cover. There is a specific cutout at the back of the top cover for the exhaust cable. Make sure to feed it through there. Then, secure the top cover using 3 screws. Now for the final step of the assembly. Take our already flashed board and plug in the USB cable. You can just leave it connected to the UART USB port. Next, connect the I2C connector and mount the board into its final position. Secure it with 4 screws, 2 at the top and 2 at the bottom. Let's turn on the power and wait for the interface to load. Everything looks great, but the screen is upside down. No worries, just head into Settings, go to Theme Color, and you'll see a 180 button in the header. Tap it, and ta-da! The image flips right side up, and we are completely done. As you can see, the build is very straightforward, especially when using the custom PCB. A quick troubleshooting note. If your board doesn't power on and you're staring at a black screen, you most likely have a mixed-up pinout somewhere. Before panic sets in, try disconnecting all the cables and plugging them back in one by one to isolate the culprit. Thank you so much for watching. I really hope this device brings value to you and your family. Breathe clean air, and bye for now.